Next is the polynomial functions. Polynomial functions. What are polynomial functions, or what is a polynomial function? Polynomial function in variable x of degree n is of the form p of x is equal to a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 plus plus a sub 2x times x squared plus a sub 1x plus a sub 0. Okay, the ellipsis there, the dot meanings there are still a lot of terms. There are still finitely many terms in between those two terms. Now, where a sub i's, the a sub n, the a sub n minus 1, the a sub 2, the a sub 1 are element of real numbers, and a sub n is not equal to 0. And take note, n is a non-negative integer. So, example, before we proceed to our example, actually, linear functions, quadratic, and even constant functions are polynomial functions. So if this a sub i's here is 0, so what will happen? P of x is equal to a sub 0. If and a sub 0, whatever the value of that is real number, then that function is a constant function. Now, if a sub n to a sub 2 are zeros and a sub 1 is not equal to 0, then that function is a linear function. Then, if a sub 2 is not equal to 0, but a sub n to a sub 3 are zeros, then that function is a quadratic function. So, therefore, constant, linear, and quadratic functions are examples of polynomial functions. Also, f of x is equal to 2x cubed plus 3x squared plus 1, and g of x is equal to x to the 5th minus x plus 1 are examples of polynomial functions. These are polynomial functions. However, if we have m of x is equal to x to the 4 plus square root of x minus 3, and n of x is equal to x cubed minus 2x squared minus x to the negative 1 plus 1 are not polynomial functions. These two here are not polynomial functions. Okay. Why? M of x, this square root of x here, that's equivalent to x to the 1/2, and 1/2 is not an integer. So we have a condition here that n is an integer. Now, in the second example here, negative x to the power of negative 1, that is 1 over x. Okay? So when you say 1 over x, and x here is negative 1, it fails the condition, it violates the condition that n is a non-negative integer. Now, aside from constant, linear, and quadratic function, I'd like to add another polynomial function which is 1 degree higher than the quadratic functions, and that is cubic functions. A function f is a cubic function if f of x is equal to ax cubed plus bx squared plus cx plus d, where a is not equal to 0 and a, b, c, and d are all real numbers. So this is a condition, a is not equal to 0, because if a is equal to 0, then that function is just a quadratic function, not a cubic function, although that is still a polynomial. So how do we graph cubic function? Example of cubic functions are f of x is equal to x cubed, f of x is equal to negative x cubed, f of x is equal to x cubed minus x squared minus 4x plus 4 are samples of cubic functions. The highest degree of that polynomial is 3. So how do we graph? So let's graph first our first example, the most basic cubic function, which is f of x is equal to x cubed. So we can use tabular method here, meaning we can just find random values. We can just choose random values of x and solve for f of x so that we could have ordered pairs in the rectangular coordinate system. This is our x and this is our y, and that is our RCS. So if x is 0, solve for f of x, that's also 0. So we have an ordered pair which is 0, 0. Now when x is 1, our f of x is 1. So 1, 1. This point here is 1, 1. Now when x is 2, our f of x is 8. When x is 2, our f of x, assuming, is 8. So that's 2, 8. Okay, how about on the other side of the origin, which is the left side? When x is negative 1, our f of x is negative 1. So here, it is 1. So that's negative 1, negative 1. Then when x is negative 2, when x is negative 2, our f of x is negative 8. So somewhere here, that's negative 2, negative 8. Then you can connect the points. You can connect the points. So we have okay. This is our function, which is f of x is equal to x cubed. Actually, the graph of cubic functions are in this form or in this form, depending on the coefficients of the variables. Okay. Now let's graph the other one, which is f of x is equal to negative x cubed. So again, we can use tabular form, x, f of x. When x is 0, this is 0. When x is 1, this is negative 1. When x is 2, this is negative 8. When x is negative 1, this is 1. When x is negative 2, that's 8. So if we graph this one, we have 0, 0. We have 1, negative 1. 1, negative 1. Then we have 2, negative 8. Here. 2, negative 8. Then we have negative 1, 1. Negative 1, 1. Negative 1, 1. Then we have negative 2, 8. Negative 2, 8. Somewhere here. Negative 2, 8. Then connect the points. So the graph looks like this. Okay. So this graph here is f of x is equal to negative x cubed. So in both graphs here, it is obvious that the domain is all real numbers, because that is extended from negative infinity to positive infinity, and the range is also real numbers. Both examples, both graphs, and both functions. Next, what if we have the third one, which is f of x is equal to x cubed minus x squared minus 4x plus 4. Although we can do the tabular method, but it will take us too long, especially if we cannot find the right, not right, if we cannot find the nearest, or we cannot find the important ordered pairs. Okay, we cannot find values of x that would give us very significant ordered pairs in graphing cubic functions. So in this case, how do we graph without using the tables? So first, we will solve the x and the y intercept. Solve the x and y intercepts. So first, solve for y intercept. Again, y intercept is values of y when x equals 0. So let x equals 0, then f of 0 is 0 cubed minus 0 squared minus 4 times 0 plus 4, and that is 4. So we now have an ordered pair, which is 0, 4. Then next is solve for x intercept. Intercept or intercepts. So let y equals 0, or f of x equals 0. Then we have 0 is equal to x cubed minus x squared minus 4x plus 4. How do we solve this one? We will try factoring, if we could factor this one. So we could do factoring by grouping, since it has 4 terms. So we can group x cubed minus x squared plus negative 4x plus 4. So we can factor out x squared in the first parenthesis, which is x minus 1 here, plus you can factor out negative 4, so that's x minus 1. So common factor x minus 1, we have x minus 1, x squared minus 4. But x squared minus 4 is a difference of 2 squares, and that is factorable. So that's x minus 1 times x minus 2 times x plus 2. So this is now the factor. Since this is equated to 0, we can use the zero product property, which is x minus 1 equals 0, or x minus 2 equals 0, or x plus 2 equals 0, implies that x equals 1, x equals 2, x equals negative 2. Now, simply the ordered pair, since y here is 0, or f of x is 0, this is 1, 0, this is 2, 0, and this is negative 2, 0. Now, we can locate those points. These are important points in the graph. First, this point here, which is the y-intercept, 0, 4. We have 1, 2, 3, 4. This is 0, 4. Then the 1, 0, this is 1, 0. This is a point here. Then 2, 0. This is another point, 2, 0. Then we have negative 2, 0. 1, 2, That's negative 2, 0. So meaning, the graph of this function passes through these 4 points. Then we just have now to locate other points that will give us direction. For example, we can take this value of x here and substitute to our x. This x here is negative 1. So what is, if x is equal to negative 1, what is f of negative 1? That is negative 1 cube minus negative 1 minus negative 1 squared minus 4 times negative 1 plus 4. So that's negative 1 minus 1 plus 4 plus 4, that's 6. So we have an ordered pair, negative 1, 6. So here we have negative 1, 6. 4, 5, 6 here. This is negative 1, 6. The next is from this point, okay? So we can take negative 3. X is equal to negative 3. What is f of negative 3? That's negative 3 cubed minus negative 3 squared minus 4 times negative 3 plus 4. This is negative 27. This is minus 9 plus 12 plus 4. That is negative 20. Okay? So assuming this is like this, negative 3, we have negative 20. We have negative 20. That's negative 3, negative 20. Actually, you can connect already here. You can connect. Let's use blue. Okay. But what will happen from this point here and these points here? What's the direction of the graph? Okay, let's solve that one. Okay, let's use here, say between 1 and 0, we have 1.5 or 3 over 2. So if x is 3 over 2, our f of 3 over 2 is 3 over 2 cubed minus 3 over 2 squared minus 4 times 3 over 2 plus 4. And that is 27 over 8 minus 9 over 4 minus 6 plus 4. This is 8. 27 minus 18 minus 6 plus 4 is negative 2 times 8, negative 16. That's negative 7 over 8. So we have 3 over 2, negative 7 over 8. So here, somewhere here, this point here is 3 over 2, negative 7 over 8. Okay. Now let's take another point after 2. So that's 3. What will happen if x is equal to 3? F of 3 would be 3 cubed minus 3 squared minus 4 times 3 plus 4. This is 27 minus 9 minus 12 plus 4. That's 10. Okay, so this point here is here, 10. So this point here is 3, 10. Correct? Now you can we can continue our graph. This is like this, and connect to that. So this is our function, which is f of x is equal to x cubed minus x squared minus 4x plus 4. So here, our domain is still all real numbers, and our range is still all real numbers. So again, what's the most important thing to do first is find the x and the y intercept. Then after finding, just locate arbitrary ordered pairs by looking for arbitrary values of x near those x and y intercepts, and solve for the f of x, so that you will be able to solve the ordered pairs. We have practice problems here. We have f of x. Try to graph this one. X cubed minus 27. F of x is equal to x cubed minus 9x. We also have f of x is equal to x cubed plus 9x squared plus 14x. Then we have f of x is equal to negative x cubed minus 4x squared minus 3x. Okay. Question?